Imagine the Earth as a big ball that's spinning on its axis. Now, draw an imaginary line from the top to the bottom of this ball. That's called the Earth's axis. Now, if we extend this line infinitely into the sky, we reach a point in the sky that's called the North Celestial Pole. But here's something even more interesting. There's a star called the Pole Star, or Polaris, which is located almost exactly at this point, just about 0.65 degrees away. What does that mean? It means that when you look up at the night sky from Earth, it seems like Polaris doesn't move at all. It's as if it's nailed in place in the sky. Today, we want to uncover this strange mystery and solve the puzzle of why the pole star stays fixed, once and for all. So stay with me until the end of this video, because what you're truly about to hear will probably change the way you see the entire sky. Imagine you're somewhere on a cold autumn night where the sky is really clear, like in a remote place with no light pollution. Or maybe on top of a hut behind an observatory, or even on a bridge with a wide view of the sky. Now, if you gently tilt your head upwards to the vast sky, close your eyes for a brief moment, and then slowly open them, you'll clearly see the expansive night sky. It's like the countless stars are gracefully moving, but in the midst of all this apparent motion, suddenly one particular star truly catches your eye because it doesn't move at all. That's the one shining up north in the sky, and it's called Polaris, or the North Star. That's when things get interesting. You decide to capture this moment. You have a camera and you set it to long exposure, say 30 seconds, and then you take your shot. When you look at the photo, the other stars appear as curved streaks of light because they moved during those 30 seconds, but the North Star has stayed almost completely still. Why do you think that is? Let me tell you, because the angle Polaris makes with the celestial North Pole is only about 0.65 degrees. This angle is so incredibly small that the North Star appears almost stationary because it's so very close to the celestial North Pole. Break time equals 0.5s/. Its rotation is really tiny, meaning it only traces a small circle about 1.3 degrees in diameter in the night sky, which the average human eye can't notice or distinguish. Let's break this down a bit more. The Earth's axis of rotation is like an invisible straight line that runs through the center of the Earth, extending out at the North and South poles. But this axis is almost pointing at the North Star. So, if you draw a straight line from the center of the Earth through the celestial North Pole, you pretty much end up at the North Star. That's why, when the Earth rotates on its axis, the star stays almost fixed in one spot in the sky. Let me give you an example to make it clearer. A bicycle will also spins around a fixed bolt without the bolt itself moving. Actually, if you look at a moving bicycle wheel, it's like a circle that is spinning around a central point. That fixed bolt in the center of the wheel is like the North Star, and the wheel itself is like the other stars that revolve around the North Star. So, when the Earth completes a full rotation on its axis every 24 hours, we, who are on Earth and rotating with it, feel like the sky is spinning around us. That's why it seems like the stars rise from the east every night, move toward the west until morning, and then set. This apparent movement of the stars is called the daily motion of the stars. In short, all the stars have this apparent motion, except for the North Star, which only traces a very tiny circle, about 1 to 3 degrees. Its movement isn't noticeable, and from our perspective, it almost appears stationary. Let me give you another example. Think about the sailors of the 15th century. Back then, there was no GPS and no precise compasses like we have today. So at night, sailors would find their way by looking at the sky. In all this, the North Star was like a celestial lighthouse for them, always shining at the same spot in the northern sky. It was telling them, "Hey, pay attention, North is here." In this way, thanks to the North Star, sailors could avoid getting lost at sea. Another example of this goes back to the Polynesian navigators. Actually, this goes way back before that. That is, around the 1st centuries BCE to the early centuries CE, the Polynesian navigators began sailing the Pacific Ocean. At a time when there were no paper maps or modern compasses, they navigated only by looking at the sky. With highly advanced knowledge of astronomy, by observing constellations and of course the North Star, they traveled thousands of kilometers across the ocean. In short, Navigators from long before the Vikings to the European explorers reliably relied on the North Star to find true north. But the North Star has also played a very important role throughout history, especially during the era of slavery in America. Many slaves who wanted to escape toward freedom and reach the North or Canada used the North Star for guidance. They had a colloquial saying, "Follow the drinking gourd," which meant follow the water dipper. This phrase referred to the Big Dipper constellation, which they could use to find the North Star and determine the direction of north. So how does it work? Well, the method for finding the North Star using the Big Dipper constellation is really interesting and simple. The Big Dipper is a group of stars that resembles the shape of a large water dipper. At the edge or lip of the dipper, there are two stars called the pointer stars. These two stars point directly toward the North Star. That means if you draw an imaginary straight line from these two stars outward from the dipper, this line in the sky will lead you to the North Star. So, when the slaves were looking for north, they would find the Big Dipper constellation. Then they would follow those two stars at the end of the dipper's edge and reach the North Star, which is exactly nearby. In this particular way, the prominent Big Dipper constellation was frequently used as a significant navigational sign to guide runaway enslaved individuals toward their freedom. But what are the different views about the North Star being fixed? Some people might ask, is the North Star exactly in the center of the sky? You could say, not exactly. It's about 0.65 degrees away from the actual celestial North Pole. There's a distance. That means it's just a tiny bit off from the center. So, it's true that with the naked eye, we see the North Star as fixed. But if we had a super advanced, highly precise camera, we'd see that the North Star actually traces a small circle around the celestial North Pole point. Now, another question, if the Earth's axis is tilted, about 23.5 degrees, why doesn't the North Star move during different seasons? The answer is simple. It's true that the Earth makes a full orbit around the Sun in about 365 days. But the reason for the changing seasons is the tilt of the Earth's axis, not our distance from the Sun. Now, here's the main point. This tilt of the Earth's axis always points in the same direction. So even though the Earth orbits the Sun, the direction of that tilt doesn't change. That's why, in every season, the Earth's axis is almost always pointed toward the North Star, and we see that star in the same spot in the sky all year round. But there's another point. As the Earth spins, it also has a slow, wobbling motion that gradually changes the direction of its axis. It's like the axis is drawing a tiny circle in space. This motion has a name. It's called the precession of Earth's axis, or axial precession. Let me give you a simple example of this. If you spin a top on the ground, if you look, you'll see that the tip of the top also slowly traces a small circle on the ground. Well, Earth's axis does exactly the same thing in space, but much more slowly. And over a long period of time, that is, a full cycle of this rotation takes about 26,000 years or 260 centuries. Now, what does this have to do with the fixed position of the pole star? Naturally, given all this, during the lifetime of the pole star, it pretty much stays in the same spot. Now you might ask, where exactly are we on the path of precessional movement right now? In the 21st century, that is, between the years 2000 and 2100, the pole star is experiencing its closest distance to the celestial North Pole. But soon, in about 400 to 500 years, the pole star will gradually start to move away from the pole. Because the Earth's axis continues its path in the precessional movement. That's why, in a few centuries, another star will take the place of the pole star because Polaris will no longer be the closest star to the celestial North Pole. More precisely, about 3,000 years from now, a star called Gamma Cephei will reach a closer position to the celestial North Pole and will take over the role of the pole star from Polaris, and about 12,000 years after that, the star Vega will become the pole star. But right now, Polaris is the pole star, and astronomers have been amazed by the Polaris star system. This star is actually a triple star system, meaning there are three stars together that orbit each other. Polaris A itself is a very large and bright star, a supergiant, and next to it are two smaller stars. One of these two smaller stars is only a few billion kilometers away from Polaris A, which is considered close by astronomical standards. That's why the Hubble Space Telescope has only recently been able to see these smaller stars and study them up close. So, there might still be a lot of secrets about Polaris that we don't know yet. But in my opinion, in this unstable world, where everything is spinning, moving, and chaotic, having a point in the sky that's almost fixed, that gives us direction is truly calming. In a way, it connects us to a single point in the sky. It's like Polaris is a cosmic lantern always up there, saying, "Don't worry, I'm watching over you. As long as you have me, don't be afraid of getting lost in this chaotic world." Even after many years, when Polaris gives up its place to other stars, every generation in a vast timeline has its own pole star, just like an eternal sign for escaping from all chaos, disorder, confusion, or turmoil. It's this contrast between the constancy of the pole star and the movement of everything around it. It's truly a symbolic and powerful image. It's as if constant change, there's room for conversation. Now it's your turn. If you have experience with stargazing or astrophotography, or even personal feelings about the night sky, I and the others would truly very much love to read about it, so be sure to share your valuable thoughts. But what we learn from Polaris, in short, is that Polaris is located exactly at the point toward which the Earth's axis of rotation is pointing. That's why it's almost always seen as fixed in the night sky. But the reason we call it the North Star is because it's only slightly offset from the celestial North Pole. In fact, its daily movement due to Earth's rotation is so small it's like a tiny circle that the naked eye can't even detect. So for us, this star seems completely fixed. Of course, on the other hand, because of the precession of Earth's rotational axis, Polaris's position isn't fixed forever. Over thousands of years, Earth's axis slowly changes direction, and, as I mentioned, other stars, like Gamma Cephei or Vega, will take Polaris's place as the pole star in the future. So this fact not only speaks to the beauty of astronomy, but also shows the amazing harmony between nature, time, and humanity's journey through history. How stars, generation after generation, have lit the way. They have been there, and yet they won't always remain the same.